In this video, we will look at how to apply colors and materials in Mobius. In the previous video, we introduced you to attributes and topology. Color is an attribute on the vertices. To be recognized as a color, the attribute must have the name RGB. The value is a list of 3 numbers that specify the red, green, and blue components of the color. Here is an example of a red polygon. To get the polygon vertices, we can use the query.get function. And to set the color, we can use the attrib.set function. There are 2 other ways to achieve the same thing. The second way uses the hash and its shortcuts. The third way uses the visualize.color function. This is a convenience function for setting the color on any entity. All 3 ways end up doing the same thing. They all create an RGB attribute on the vertices and set the values. Let's have a look at materials next. Polygons in the model define a surface. That surface can have material properties other than color. If no material is defined, then a simple matte material is assumed. However, you can define your own materials with additional properties. For now, we will only look at one material, which is the glass material. The glass material has a transparency setting. A material is applied in 2 steps. In the first step, you define a material, giving it a name and a set of properties. In the second step, you apply this material to 1 or more polygons. You apply it using the material name. This means that if you have many polygons with the same material, you are not redefining the properties multiple times. The properties are only defined once, in the material definition. That one material can then be applied to many polygons. The material properties are defined using the functions in the material category. For glass, we will use the function material.glass. The function has 2 arguments, the material name and the transparency. In the example, we call the material glass. The material definition is actually saved as an attribute in the model. So if you click on the Model tab in the attribute table, you will see that a material called glass has been defined. The value is a dictionary data structure containing all the settings for the glass properties. In the second step, we now want to apply our glass material to our polygon. This requires the polygon to have an attribute called material with a value glass. There is another convenience function for doing this. It is the material.set function. The first argument is 1 or more polygons. The second argument is the material name. This second argument must match the name of the material exactly. Finally, let's look at one more function that can be used for setting colors. This is the visualize.gradient function. The function will take any numeric attribute and convert it into a color using a color scale. The function has 4 arguments. The first argument is the list of polygons to add color to. In this case, we get all the polygons in the model. The second argument is the name of the attribute to use for creating color. In this case, it is called height. The third argument is the numeric range to use for the height attribute. In our case, the height varies from 0 to 100, so we give a value of 100. We could also have specified a list of 2 number, in which case the range would be from the first number to the second number. The fourth argument specifies the color scale to use. In this example, we use a false color scale that varies from blue to red. In order to demonstrate how this function can be used, we will apply colors to our spiral steps. To do so, we first create a glass material. Then we set the material for all polygons in the model to glass. We take the Z values of all the positions in the model and push them up to the polygons, renaming to height along the way. Finally, we then create the color gradient for all the polygons in the model.